Hello students. In our previous video, we learned about resistance and resistivity. Today, in this video, let us learn the different ways of connecting the resistors in circuit. Here, we will also learn about the series combination in detail. Before proceeding further, let us refresh terms like resistance, resistors and resistivity, which appear to be the same but are different. Let's first take the term resistor. It is a component or device with a resistive behavior that is used in an electric circuit to regulate the flow of electrons. The next term is resistance, which is a property of resistor to oppose the flow of current. While the measure of this resistive behavior of a resistor is called its resistivity. For example, look at this device on the screen. This is a simple resistor. It has a property to resist the flow of current, and this property is called resistivity, which is measured in ohms meter. Students, today we will connect resistors in various combinations and see their effect on current and voltage through Ohm's law. In various electrical gadgets, we often use resistors in various combinations. We now, therefore, intend to see how Ohm's law can be applied to combinations of resistors, or in other words, how to calculate the total resistance of resistors joined in different combinations. There are total two methods of joining the resistors together. In figure 1, the electric circuit has three resistors having resistance R1, R2 and R3 respectively, and these are joined end to end. In this condition, we say that the resistors are connected in series, while figure 2 shows a combination of resistors in which three resistors R1, R2 and R3 are connected together between points X and Y. Here, we say that the resistors are connected in parallel combination. Let us explore each type of combination with the help of an activity. Look at this circuit carefully. In this circuit, three bulbs are connected in line, end to end in a series combination. When connected in series, a single charge coming passes through every light bulb as they are connected end to end. If we talk about whole current passing in the circuit, we can say that the same current will pass through all bulbs. Also, the bulbs in the circuit light up dimmer as we add these bulbs, one after the other. Also, if we keep adding bulbs more and more, their glow becomes dimmer further. We also observe that if we remove a bulb from this circuit, then remaining two bulbs in circuit stop glowing. Remember students, the filament of the bulb is a resistor only. The main questions of concern from this activity are: as the number of resistors increases, what happens to the overall current within the circuit? As the number of resistors increases, what happens to the overall resistance within the circuit? If one of the resistors is turned off, what happens to the other resistors in the circuit? Do they remain on? Let us answer them and in turn understand series connection in detail. Students, we know that this circuit is an example of resistors connected in series combination. Here we can see that a voltmeter and an ammeter are connected in the circuit. From these, we can measure the potential difference and current in the circuit respectively. We call these V and I respectively. Now, let's disconnect the voltmeter and connect it like this to measure the potential difference across each resistor. From here, we observe that potential difference across each resistor changes and is less than overall resistance. Accordingly, get the potential difference across the first resistor R1 is V1, across R2 is V2 and across R3 is V3. And V1, V2 and V3 are smaller than the voltage of external battery V. Now let's change the position of the ammeter and measure the current at different positions in the circuit. Now, since this is important, let me explain you again. Look at the screen. You can see that in position 1 of voltmeter, it shows the potential difference or voltage of the whole circuit, and this is different to the voltage in the individual branches. This means that series connection is voltage divider. While now look at the readings in the ammeter. They are same at both the locations. In fact, the current in the whole circuit is equal to the current in the individual branches. This means that current remains same. Here we see that the same current I flows in the entire circuit. So here in the series combination, only the total voltage V of the battery is divided at each resistor as per the values of resistance. That is, there is a voltage drop. In simple words, a series combination is a voltage divider. We can calculate the values of voltage drop by Ohm's law. We know that the total voltage of the circuit will be the same as that of battery's voltage. So the voltage across the three resistors will be equal to the sum of the voltage across the individual resistors. We can write this as V total is equal to V1 plus V2 plus V3. By Ohm's law, V total is equal to I into R total. V1 is equal to I into R1. V2 is equal to I multiplied by R2. V3 is equal to I multiplied by R3, where I is the amount of current and R is the resistance. Replacing V in equation, we get I multiplied by R total is equal to I multiplied by R1 plus I multiplied by R2 plus I multiplied by R3. Taking I common on both sides, we get I multiplied by R total is equal to I bracket R1 plus R2 plus R3 bracket close. Since the current flowing through the circuit I is constant, so we get R total is equal to R1 plus R2 plus R3. So for series combinations, we can say that if more resistors are added, then the overall resistance of the circuit increases. And then according to Ohm's law, the current within the circuit decreases. This decrease in current is consistent with the observation that the bulbs glow dimmer in the circuit. A final observation that is unique to series combination is the effect of removing a bulb from a socket. If one of three bulbs in a series combination is unscrewed from its socket, then it is observed that the other bulbs immediately go out, because if one resistor is removed or damaged, then it will cut off the flow of current in the circuit. This means that the combination in which the resistors are connected has a major effect on overall resistance of the circuit, the total current in the circuit, and the current in each resistor. Students, in this video, we have learned the series combination of resistors in a circuit. We learned that in series combination, different resistors are connected end to end. The current across all resistors remain the same, while there is a drop in potential difference across each resistor. Also, we learned that when several resistors are joined in series, the total resistance of the series combination Rs equals the sum of their individual resistance R1, R2, R3, and is thus greater than any individual resistance. In our next video, we will learn about parallel connection of resistors.